everyone to the first skills development workshop. My name is Tracy Luceno, and I will be taking you today through descriptive statistics and factor analysis, and I will be using SPSS to do so. Now, for future skills development classes that we'll be running, we do plan to advise you and direct you on different packages or software packages that you can be able to download, and that would be quite useful for you to access, as well as get some data that you can play around with and be able to understand how to use them for your data analysis. So for today's session, I will be taking you through, I'm going to maximize this for you. So I will be taking us through 4 different parts. The first part will be looking at understanding what statistic is, and then we'll look at descriptive statistics and try and understand of the 2 different types of statistics that exist, why we're focusing on descriptive statistics and its relevance. We will also go through exploratory factor analysis. Now, this is part of an analytical approach known as structural equation modeling. And the reason we'll be doing this is because often you find that conducting an exploratory factor analysis helps you understand your data better and also be able to access or retrieve the appropriate data. So if you're conducting a pilot study, like in my case, where I'm now able to identify what specific questions and what specific variables are quite important for my research. And then I will shortly give you a practical session. So I will take you through SPSS and try and show you how to read or use descriptive statistics on the SPSS software. And it's quite easy. And as you do it, I do advise that feel free to go ahead and download SPSS package. You can be able to get some free trial, so it could be a 30-day one, and in doing so, you're able to also access data that you're able to play around with. So that gives you the ability to manipulate or understand the data set that you can have access to. And you also do have the ability to ask on the ASF platform for, if you're unable to access any data, for people to provide you with such. Okay. So what this particular session intends to give you as part of the learning outcomes is that you'll be able to gain some relevant information that's quite useful when it comes to data analysis, particularly using SPSS. You'll also be able to research and organize data from multiple sources in appropriate formats. So the reason I've stated appropriate formats is because when you're working with your data, it's quite good to know what kind of variables or the type of data that you're working with. So whether it's like a Likert scale, how to frame it, and what kind of representation it is on SPSS. You'll also be able to categorize your data for analysis. What that simply means is you learn along the way, as we'll be looking at data, both particularly in the practical session, where you're able to understand or look at, if you have 10 questions that are trying to address the same factor, how exactly do you identify the most important questions for that particular factor, and how can you be able to realize which ones are important and which ones can be discarded from that particular data set. You'll also be able to recognize certain patterns and also be able to determine what they mean, as well as evaluate the evidence to identify the best variables to use. You'll also be able to communicate some of the findings and recommendations clearly. And of course, by the end of the session, you're hopefully able to conduct both descriptive statistics and exploratory factor analysis using SPSS, right? So for the first part, we're going to look at understanding what statistics is. Now, defining statistics or describing it in one sentence, I'm sure you all have certain definitions or off the whim that you would go for. And in and around, most likely it has to do with trying to look at certain information and try and decide its appropriateness. Or in some cases, you're also trying to tabulate. It could be in the form of numbers, or it could be in the form of categories. So it all depends on what your definition or your understanding of statistics would be. But officially, one of the best ways to look at what statistics is, you would state that statistics is the practice or the science of collecting and analyzing numerical data in large quantities, especially when it's for the purpose of inferring proportions within a represented sample size. Now, statistics comes in two different types. You have your first form of statistics, which is descriptive statistics. Now, these are often used to report on populations and samples. This is where you're able to organize your data, you're able to summarize it, simplify it as well, and be able to summarize some of that information, which becomes more comprehensive according to a specific group that you're looking at, and identify similar characteristics that exist within that particular group. Now, we'll be focusing on descriptive statistics today. But you do also have inferential statistics. Now, this is whereby often researchers end up making certain judgments or coming to certain conclusions. This is where the hypothesis testing often takes place, and also trying to understand the certain relationships that exist amongst variables. Okay, so that's something that we'll potentially, hopefully, look at in future sessions that we will be holding. So depending on the kind of research that you're engaged in or you are planning to engage in, there's certain research methods, or you have to think about whatever research methods that you intend to go for. Now, you have an option between going for qualitative or quantitative, or in some cases, like myself, using a mixture of both. The qualitative research often involves collecting and analyzing non-numerical data. So this is where you try and discover certain theories, or try and seek to understand how a certain demographic or group, what factors or what variables are similar amongst them. You're also trying to explore process. So it could be in an example of a case study. So perhaps you trying to understand what economic factors provide or exist within a certain country and drive either their economic growth or perhaps even their economic downfall. It could also be that you're trying to describe experiences, or as well just trying to report on certain stories. You also have the quantitative research. Now, this is very numerical focused. It often focuses on the relationship between variables that you're trying to explore. So you may therefore end up trying to compare certain characteristics using an independent variable to a dependent variable. So it could be you trying to understand how education or the level of education impacts someone's ability to access employment. Okay, so here there's certain specifications of research questions and hypotheses that are formed that are often trying to test a certain theory. Okay. So when it comes to analytical approaches, there's quite a number of few of them. Some of them are often informed by the type of research method that you've opted to go for. Now, the first one on here, what we have is known as structural equation modeling. Now, this is just when a researcher is combining factor analysis and multiple regression and trying to create a structural relationship. So it's trying to create a visual to measure the variables and latent constructs that they've come up with in their research. So in this case, for our session today, SEM is part of what we will be touching on, and we will be looking at it more from an exploratory perspective. So trying to understand our variables and what communalities do they have amongst themselves to try and create a more precise or a particular one specific variable that could potentially represent 5 or more, or however many variables that I will be looking at. Okay. We also have panel data analysis. This is where a researcher intends to look at a subject within multiple sites and observe it over a defined time frame. So it just enables an array of techniques to try and resolve or remove a certain bias in estimating the treatment effect. Now, there's certain things that one would be looking for when conducting panel data analysis, which includes the propensity score matching. So these are all items that you will be able to understand in the future sessions, the workshops that we will be hosting. Also, looking at what is known as double difference and instrumental variable models. Okay. You also have what is known as social network analysis. So this is simply as it states, you're just trying to investigate the interaction and linkages which runs between individuals or agents within your study in a relational system. So you're trying to confirm whether there's an existence or a lack thereof of a relationship that exists between whatever you will be studying. You also have content analysis. This enables the researcher to interpret meaning from the context of text data. So it's more, it gives you an ability to use coding to transform some of that qualitative data into forms of quantitative data. If you're conducting, let's say, an interview, you're going to try and create certain commonalities amongst the information you'll retrieve from your the individuals, your participants, to try and create or maybe create an understanding or try and make your work more reliable. You also have case study research. So it's providing a detailed contextual analysis, focusing on a limited number of events or conditions, and trying to understand the relationships that exist within that particular context. The ethnographic study is one where people employ it and they place themselves within that specific environment that they're researching on. So you find that it could be analyzing their social interactions or behaviors within a specific context. And you use different ways to try and record that information or collect that data. So it could be you conducting a direct observation, or you keeping a track using a diary, video recordings, artifacts, photography. It could be whatever one opts to go for. Now, QCA, what is known as the qualitative comparative analysis, is one that's relatively new. So it is one that uses a mixed method, and it intends to look at the gaps that exist between case study research and quantitative research. So this is particularly one that you would go for if you're trying to have a combination of a mixed method analysis and you want to understand the specific context that you have chosen or gone for. Now, these analytical tools of analytical approaches, of course, have certain analytical softwares or packages that you can go for. Now, this here, this particular slide just gives you or showcases some of the ones that you'd go for. So in the case of, let's say, structural equation modeling, you do have the option to use SPSS when it comes to exploratory factor analysis. RStudio could also be used for structured equational modeling. And Vivo is one that you opt for, because it helps you with coding, particularly if your approach is more of a qualitative one. So given that you have all of those, when you're trying to focus on the data that you have collected, you do have to analyze those variables that you've gone for. Now, of course, you have to try and figure out what exactly is a variable, what definition or what would be the underlying basics or the key components that describe a variable. So you find that a variable holds any characteristics, numbers or quantities that can be measured or counted. You find that it is called a variable, key term variance in it, because the value may vary between data units within a population and may also change in value over time. So you do find that these are some of the key principles that can describe a variable that you're working with. So looking at the types of data that you do come across, you find that depending on whether your data is related to quantity and can be measured, it can become numerical. Or if it is related to quality and cannot be measured, it becomes what is known as categorical. Now, the categorical data is one that's quite descriptive in nature. So the qualitative aspect where you've done your interviews or you're trying to measure certain items according to different categories that they fall under. So examples are whether you're trying to assess whether something's cheap or expensive, whether something's small, medium, or large, or whatever sector an individual may fall under within certain examples of industries, right? So this type of data, you find that can be coded by numbers, but the codes do not mean any mathematical meaning. So it's not necessarily one that has any value in terms of ranking it from, whether if something's cheap or expensive and trying to assess their meaningfulness. You do also have numerical data. Now this comes from the quantitative aspect, where you find that the data can be assigned a value. It can take any form and thus can therefore have certain measurements placed on them. So if you think about certain things as if you're inquiring about price, if you want to find out your population's height, or maybe even their weight, or the number of stores in a city. So these kind of examples is what you would place under, or these kind of data is what you would place under numerical types of data. Now, when it comes to the types of variables, keeping in mind that you trying to identify what type of, to address or assess what kind of variables you have within your instrument, it depends on the categorization. So you find that if you're trying to categorize it by the level of measurement, then of course it either becomes categorical or numerical. Now, in the categorical aspect, you find that it can either be nominal or discrete, and whereas in the numerical category, you find that it can either be ordinal or scale, or depending on either interval scale or ratio scale. But if you're trying to categorize it by the type of control, you also find that this is more when you're now running your analysis, which one's going to be your independent variable? What are you going to have as your dependent variable? And what will you be placing as the control variables? Now we'll go through looking at the categorization by the level of measurement in our next slide. Now, when you're trying to categorize by the level of measurement, as I said, depending on the category. Now recall that there's no meaningful ranking that has been brought up when you're looking at category. So when it comes to the nominal type of variable, this is where you have no meaningful rank that has been assigned to it. So this is quite important because you find that things such as gender or marital status, you cannot claim that one is more higher in ranking than the other. Just simply because an individual is married does not necessarily mean that they're better off than those who are single. Similarly, with gender, you cannot try to state that, in this case, females are better than men, or vice versa. But you can use that data to try and understand how exactly it is influencing your analysis or the group that you're looking at. You also have the discrete variables under the categorical data. These are limited in the number of options. So you often use them when you are not trying to get specific information necessarily. So in some case, assuming that you would want to ask someone what age group they fall under. So you give them an option where perhaps, let's say it's 18 to 25. Or 26 to 35, and so on and so forth. You feel as though you give people the option, or the population size that you're looking at, the option of giving discrete information, yet you're still able to actually access important information in that population that you're looking at. When it comes to the numerical category, you do have two types. So you have the ordinal and you have the scale. Now the ordinal one, of course, now has a meaningful rank in order. So age group, again, can come under this because you're trying to, perhaps if you're assessing salaries and you want to use age groups to try and understand it, you may find that the older age groups may have higher salaries. And of course, that's telling in your data, the kind of data that you're possessing. The Likert scale as well. So think about a Likert scale, perhaps if you're trying to understand the life satisfaction scale, then you're able to understand if people are rating from 1 being strongly disagree to 5 being strongly agree. You're able to determine that those who go for 5 are perhaps quite happy in their life and how they've been going about their daily life. You also have numerical scale, numerical variables. Now, this is data that is not grouped. This is more when you leave an open response for your respondents. So it could be that perhaps you've asked your population size. What is your age? And people go ahead and fill in if they're 25, then they place that on there. So you have a value that is exact, or rather precise in this case. It could be also something such as time. So in this case, if someone was to ask at precisely what time did you start the session, then 12 p.m. would be the answer. So you have that precise data, or income as well. So trying to understand the average income, whether it's monthly or whether it's on an annual basis, then you're able to get that kind of data from your respondents. Now, when it comes to looking at descriptive statistics, these can be easily understood using SPSS as a tool. So if you use the software and you have your data at hand, which you have already, of course, categorized according to the type of variable it is. So whether you've gone for it being nominal or you've gone for it being scale, you're able to understand what exactly, you're able to look at that data, input it, and generate certain values that you can interpret and try and understand what that data is trying to tell you. Now, when it comes to descriptive statistics, there's 3 types that you're able to look at. So you can start by looking at the frequency distribution. This just tells you the number of times that samples have fallen into a particular category. So it could be that you trying to understand the number of 18-year-old people who are between the 18 to 25-year age group who earn above, let's say, £25,000. You're able to understand that using descriptive statistics. You also use graphical representations. Now, these are quite useful because you're able to see and also give a comparison to the data that has been tabulated from your analysis and try and see if they reflect each other. So things such as kurtosis or the skewness of your data. If you're trying to represent that in a histogram, you're able to actually see that does the data align with what your graphical representation is showing. And then you also have summary statistics. Now, these are quite useful because it's more to do with just trying to understand the data that you have in hand in just one number. So things such as mean, mode, median, which I'm sure are terms that you've come across time and time again, help you understand this. Trying to understand what number has shown up the most in a certain data or a certain variable, or trying to understand what is the most middle point of the numbers of the data that you have in front of you. So that kind of summary statistics. So looking at our descriptive statistics and trying to summarize them, you have 2 ways in which you can look at this. So you have the central tendency. Now, the central tendency tends to look at the middle values. So you're trying to understand the mean, the mode, and the median. And then you also have the dispersion of variations, right? So this is a summary of the differences that may exist between the different groups, particularly when you're looking at a variable that provides you with perhaps a mean that's quite being pulled by outliers within your data. So to understand the indicators of central tendency, the median in this case is the middle score, or rather the middle value. It is the value that separates the higher half from the lower half of the data or your sample size. Okay, so you're trying to look at the probability distribution as well. So it's just a number that could be telling, and particularly becomes more useful if your mean is being skewed by any outliers. So outliers are any values that could be extremes within your data set, whereby you find that perhaps it's only in an example such as salary, where you have extreme cases where maybe an individual is earning an extremely higher salary in comparison to the rest of your sample size. The mean is the average. So in this case, the arithmetic average of every single value that you have in your data set. So it is the sum of the values within that data set divided by the number of, or rather, as a result of dividing it by the number of values that are within that particular data. This is one I'm sure you're all familiar with calculating. And in this case, of course, if you're using a tool such as SPSS, it is one that's easily tabulated from you using the tools that are provided on the software. Now you also have the mode. This one's quite easy, depending on how large the data that you're looking at is. So it's the most frequently occurring score within your data set. It's easily drawn or tabulated from whichever software that you may use, or even in the most basic of tools such as Excel. Okay? When it comes to measuring the dispersion within your data set, the range simply just looks at the difference that exists between the largest and the smallest observation. So this is important because you kind of understand whether or not, what kind of relationship exists amongst your data set, what kind of other influences or what kind of other variables could be contributing to either it being a very large difference or it being a very small difference. Okay, you also have the interquartile range. Now this one simply shows the range in values of the central 50%. Now what that means is that if your data is written down and you have it running from 1 to 100, then you know that your interquartile ranges that exist are 25, 50, 75, and 100%, or rather the quarters that exist in those numbers. In this case, the interquartile range is simply the range in values that exist between 25 to 75%. Now, variance is quite important because it shows you the distance of any observations from your data, from the mean, from the perspective of the mean. So depending on whether your variance is large or small, then it does have a lot of influence, or like tells quite a significant tell in your data. You need to try and figure out or understand, in this case, what other factors could be contributing in the variance being so far large, so far away from the mean. And in some cases, of course, you find that the mean does end up being skewed by outliers. And so this could also be another factor. And it's also a tell to try and understand what your data is trying to tell you. You also have standard deviation. So this is the measure of the amount of variation of dispersion between a set of values. This is more so to try and read what that variance is trying to tell you. So it's also quite important to try and understand how exactly what your data is trying to communicate to you. So coming on to exploratory factor analysis. Now these have all been important areas or important terminologies that I would want you to familiarize yourself with, because when you're reading some of the results that you're getting from SPSS, they are quite useful to try and understand or know what to look at in order to describe the data that you have in hand. So if you find that your mean is quite high, then you try and understand what exactly is, what could be affecting it in that case. Now, similarly, when it comes to exploratory factor analysis, the terms that we'll be looking at will help you understand when we go through the practical session what it is we shall be looking for. Now, EFA is a statistical approach to determine the correlation amongst the variables in your data set. So you're trying to, in some cases, create a single factor that can represent majority of the variables that you have. So it creates a factor structure and it groups them and creates a stronger correlation according to the data that you have present with you. Okay. You do conduct what is known as a dimension reduction. So this is one where I will be showcasing you in our practical session. Now, the dimension reduction is just where we'll be transforming the data that we have. So say if I have 10 variables, I will try and reduce their dimensions to, let's say, 2 or 3 different factors that represent all those 10 variables. Okay, so you're simply just trying to create a high dimensional space and try and narrow it down to as many small factors as you can. Okay, so to do so, there's quite a number of different techniques that you use on different software packages. Now, on SPSS, the most common ones is the principal component analysis and the principal axis factoring. Okay, for our case today, we will be using the principal components analysis. This is where we'll be considering all the available variances that will exist within the data set that I will be showing you. So you'll find that in the case of whether I'm trying to study business performance, it will consider every single variation or the variance that exists amongst the business performance variables and try and create factors that can represent those business performance variables. Now, it seeks to maximize the variance that's extracted. So it will run it over and over again until it shows you what factor you can draw from it, what variables to discard if they're no longer useful for your study. And then you're able to interpret that from your analysis and come up with a single variable that's useful. So this only happens, well, you use this when there is a concern with prediction. And you want to try and remove parsimony and as well as know the specific, and you know that the specific areas and variances are small within the variables that you have, okay? When you use the PAF, which is the principal axis factor, this only considers the common variances that exist. And it also tends to only look at the least number of factors that can account for it. So unlike the principal components analysis, where you're able to extract all the factors that could possibly be represented, this will simply only give you some of the most important ones, okay? So, and it is one of the most common ones for using and analyzing. And of course, I do advise that when you do get SPSS, or if you do have it as well, try and play with both and try and understand what exactly is the significant difference amongst using the two. But often you do find that they can also give you similar results according to the variables that you have present. Now, we will be looking at the appropriateness of the data. So the variables that I have present with me, which ones are important for me to keep, and how useful are they for my factor analysis? Now, when it comes to factor analysis, you conduct the exploratory factor analysis, and then from on there, you go and conduct what would be known as a confirmatory factor analysis. So that is where you're trying to confirm that every single thing or every single variable that you have found from SPSS is found to be true, that the relationship that exists between those variables does have a significance to them. Now, in this case, prior to conducting a confirmatory factor analysis, you need to find the appropriateness of your data. Now, when you're doing so, you need to look out for what is known as a Kayser-Meyer-Oakland test. So the KMO test is as a result of constantly conducting your exploratory factor analysis. So it simply determines the adequacy of your data. So it allows you to ensure that you have suitable variables that are able to conduct a factor analysis. So when you are looking out for it, according to the diagram that you have on there, anything that's often closer to 1 is very appropriate for you to use in factor analysis. Now, depending on the kind of data you're looking at, they say most studies or most, if you're looking at a guidance in terms of the significance level, you will find that anything that is above 0.7, or rather not 7, is considered to be very good, and that variable can be used for your factor analysis. Now, of course, you also look at the Bartlett's test of sphericity. Now, these are all tabulated by SPSS at the same time. And what this does is it tries to look at the correlation amongst your variables. So trying to identify that whether or not any of the variables that you've presented have a relation to each other. Now, anything that is less than 0.05 considers that or shows that your variables do have a relationship, or rather that a correlation exists amongst them. So it is good for you to try and retain those values, especially if your KMO test shows that if your KMO test shows that it is above 0.7. Now, there's also an area that you can try and look at, and or rather I advise that you do look at, which is the communalities. So this is a table that we'll also have a look at when we run our practical session, and try and understand the variances of each variable in contributing to that factor that was created. So you'll find that each and every single variable has a certain percentage, or that was drawn from it, that created the smaller dimension that's been created. So anything that showcases that that's particularly above 0.5, in my case, that's the range that I use, then it shows that it has a good extraction point or a good communality to that variable, to the new variable that's been created. So anything that's below that, you should try and consider maybe removing that variable from your instrument, because it may affect the results, or rather it can skew the results that you're looking for and trying to understand the relationship that exists. Now, lastly, what we will look at, sorry, just need to move this, is the factor structure. Now, the factor structure is something that shows you the intercorrelations amongst the variables being tested. So this shows you that according to this image, as you see it, the BOSCs, so those that are being represented in the rows, those are the different variables that I tested in this case. And then the components, so the 1 and the 2 are the new variables that simply showcase where these variables fall under. Now remember that I'm looking at anything that's above 0.7 in this case. So you find that for component 1, every single, the BOSC 6 all the way to BOSC 1, these are the different variables that have now been compressed to create a new factor, which is 1, okay? And then you find that for the component 2, so the new factor that has been created, it is only the BOSC 10 and the BOSC 11 that are relevant, and the BOSC 7. So these 3 are quite relevant for the second component, or the second factor that has been created. Now in this case, you'll notice that BOSC 2 and BOSC 3 did not make the cut. So what that means is that I'll simply remove them from my instrument being my questionnaire. So whatever was the question that represented BOSC 2, So the bonding social capital of the second one, and the third question, I will be taking that out of my instrument, which makes it better and a stronger instrument, okay? Now, lastly, when you've come up with those components, so when you find that your reliability test or your EFA test has shown you that you can have a new variable representing BOSC6 all the way to BOSC1, and you can also have a new variable that represents BOSC 10, 11, and 7, you're going to want to test that. You're going to want to know how reliable is that test that you have just run to showcase that you can use those new variables that have been created. So it allows you to study the properties. So you use certain things such as the measurements of scale to try and analyze the relationship that exists amongst those variables, okay? So in doing so, you're able to use what is known as the Cronbach's alpha. Now, this is a model of internal consistency. So how well or how closely related are the items? So you'll find that what this test will allow me to do is identify that when I run it and it shows that BOSC6 and BOSC8 are closely related, then I should use those variables for my test, and that I should keep them and retain them. Now, the Cronbach's alpha is one that you will run with your new variables that are represented in your factor. And anything that is above 0.7, then you definitely retain or keep those variables because they are useful for your study, right? So those are some of the items that we will be looking at today for our practical session to try and understand how exactly, what do these mean when they're being run and when you're presenting them, when you're using your data on a platform such as SPSS. So before I move on to our practical session, are there any questions or clarifications that you may need? Please feel free to either unmute yourself, you can raise your hand and unmute yourself, and I will be able to clarify that. Are there any questions? Okay, so I will be moving on to the practical session. You're also more than welcome to write in any questions in the chat section, because it could be also easier to answer some of your questions on there. So I would be more than happy to refer to those and look at those once we have run the practical. So moving on to the practical, as I mentioned, I will be using SPSS today. Now the SPSS software, if you would want to play with it or try and understand how it works and try and work some of the, and do some of the tests and conduct some of the analysis that I've mentioned today, please go ahead and download it. You are able to register and get a free trial and try and work with that. You may find that it is easier for you perhaps to work with SPSS in comparison to some of the other software packages that exist. If you want, there's also some other free ones. If you're able to access R, you're able to download that. That is an open source software that you're also able to download and have and play with, okay? All right, so some of the data that you see represented here, this is data that is from that's from my research. So I am currently conducting a research that tries to look at how refugee entrepreneurs in Kenya access social capital in order to improve their businesses. Now, what social capital represents, it's basically the networks that they possess. So it's represented in three forms, or looking at social capital in three forms. Now, the first one is bonding social capital. Now, that is what you would see on this data that's represented as BOSC. Now, bonding social capital are simply the close ties that people use or rely on to try and improve their situations or their context. So it could be accessing, let's say, help from family members or it could also be just trying to understand how exactly their neighborhood sometimes contributes to their business, or trying to understand if they have friends who also operate within the same business landscape as them. There's also an element or another form of social capital that's known as bridging social capital. Now that's represented by the BRSC that you see on here. Now the BRSC, or rather bridging social capital, are more or less the relationships that one extends into or taps into from groups that they are not necessarily a part of. So it could be them extending or engaging with people who aren't from the same ethnicity as them, or them tapping or asking for help from certain networks, such as associations that they belong to, and so on. And then lastly, you have the linking social capital. Now the linking social capital, the LSC, this is simply the networks that they use that cut across power gradients. And what that means is that it basically, the entrepreneurs tap into accessing help from government officials or some of the non-governmental organizations that help refugees try and settle down or start up businesses. So to try and understand if these channels actually help them, or these networks help them access certain resources. Now, some that you're familiar with, I've also, of course, inquired on their gender. So I want to know, I want to understand maybe if there's a distinction according to maybe males have a better context or a better environment in accessing certain things, and also asked about gender, age. So age is something that will also give me some kind of intel or knowledge to try and understand perhaps maybe at what age do people start up their businesses. The marital status, I think that's also quite important to know what kind of relationship status one is in, because perhaps it will give me some understanding as to how perhaps even having a spouse may be beneficial for some of them, or in some cases, I may find that it makes no difference according to what relationship, whether or not you're in a relationship. I've also looked at their average revenue, so from their businesses. So in this case, I've looked at their average revenue across 3 different years. So 2016, 2018, and 2019. To try and understand if their businesses have grown over that period of time. I've also inquired about their monthly average salary. Now, both the revenue and salary are in Kenya shillings, so you can keep that in mind if that is something you would want to follow through throughout this analysis. Another aspect that I've also looked at, or that I will be looking at with you today, is the business performance. So this is simply represented or was asked in the form of a Likert scale. So as you see here, these have been asked in the form of a Likert scale to try and understand what they think of their sales growth, as well as profitability, their return on equity, assets, margin. So all of these, I use them as a gauge to try and understand what they think of their business performance. So what I mentioned earlier as well in terms of understanding your variables, you can see that on here, I do have the measures on SPSS represent the kind of data or the kind of variable that is. So you'll find that anything that's a Likert scale is mentioned. Because there's a ranking to the order, you do find that it is ordinal. Okay, so of course, in this case, if they think their business performance is very poor, then they were to mention to select 1 or select 7 if it was outstanding. Another example would be scale in this case, so no meaningful rank. You do see that I put that under yes and no questions, because it also gives the idea that it can be easy for me to create certain things such as histograms and graphs, depending on the kind of measure that I've used. I think another one, let's see. The nominal value here, I think that one is an error. I think the nominal values, as you can see, that have been assigned are things such as the sex that they are, as well as the relationship status, because there's no meaningful rank or order to what their answer was. All right, so the first bit that we will be looking at will be us looking through the descriptive statistics. Just need to minimize this. So in order for you to get some descriptive statistics from this, now remember what we will be looking at is we'll use some of these to try and understand what the data is trying to tell us. So we'll start with descriptive statistics, which is quite easy to access on SPSS. The first bit you may want to use, in this case, we can look at their salary to try and understand what their salary is telling us. You can find the data view. So you do get the data view, which is here. So it gives you an idea of, the salaries that they've had, because this will be a reflection of what we see. It also gives you an understanding of which ones are the males or the females who fill this in, the age groups that they fall under, their relationship status, and so on for every single variable that exists. Now we can start by looking at the salary and just try and understand what exactly is the descriptives, what representation or what descriptive statistics exist in that variable. So the first thing that you would want to do, perhaps, you may even want to get a graph that helps you understand what the salary is amongst all of them. So you can have that there, where you simply just select it. When you go on the graphs, if you select histograms as the histograms, it does bring this pop-up where you can select the salary, jot that under the variable tab or the variable slot, and then you can simply just click OK to see what it brings. Now from the graph that has been generated, let me just share my screen properly. Okay, so from the screen that is created, I'm not sure if you're able to, can I just get a confirmation that you're able to see the graph on the screen? Okay, so you do get a graph. Yep. Thank you for that, Adinka. So you do get a graph that shows you the salary distribution for this particular group. Now, from this graph, the first thing that definitely stands out is the fact that you do have an extreme value or a representation. So there's quite some gap that is represented. In this particular data from the salaries, but then it is also skewed to the left in this case, where a lot of the data as well is on the lower end of this particular histogram. But now you would want to understand this from more of looking at the statistics, at the data, so understanding what the numbers would be and how they would be represented. So you would simply just access this by going on to Analyze. You do have the descriptive statistics box. Once that is selected, you go on to the descriptives. So it's quite straightforward in terms of where exactly you access this kind of details and how that helps you get some of the information that you want. So when you select descriptives, you're able to grab, I'll just reset that for you, the average salary. So all your variables are represented there. So if you select the average salary and point it out to the variables tab, you're able to now set certain options to try and see what it is you'd want to read. So assuming that you want to get the variance, right? So you want to understand what exactly is the difference amongst each and every single value from the mean. You'd also want to get the range, which shows you the difference between the highest salary and the lowest salary. You'd also want to get the kurtosis, which will show you which of the tail end, if this was represented in a histogram, how exactly that would look like. And you want to get the skewness. Right. So one thing you should note in this case is that what's lacking is the central tendency. Other than the mean, the mode and the median aren't being represented in what you're doing at this very moment. So that's something that perhaps if you're interested in terms of like finding out, that is very dependent in terms of what the mean is going to tell us, right? So pressing continue, it simply brings about it draws that out for you and it brings it down on here. So what you see is that the first thing to note is that this particular study had 60 individuals participate into it, right? So the reason that being, I was conducting a pilot study and ideally this was a good number to try and work out because it is 10% of the population that I would be aiming for. So for my main study, I do intend on having 600 individuals participate. Now, looking at the statistics that have been given, you find that it gives us a range. So the range is the difference that exists between the minimum salary and the maximum salary that exists within the data. So 34,000 is the difference between the person who's earning the most and the person who's earning the least. Now, in this case, the lowest earning person or the lowest earning individuals earn 2,999 shillings, which isn't quite a lot. It's $29 a month, right? And then you find that the highest individual earns 37,024. Now, you also have the mean. Now, the mean in this case, if you're to look at it and if you're to do a comparison between the minimum individuals, so the people who earn the least, you find that these people, the mean lies that it's almost 12 times the lowest earning individual. So that's quite important information. It would make me want to try and find out what other factors exactly are contributing to the fact that this person or these people are earning quite a low salary. So I could try and identify and also perhaps use some of the other variables to try and understand what these numbers mean. Now, similarly, if you compare the mean statistic to the highest earner in this group set, you find that it's almost a little bit over twice as much as the maximum, twice the maximum salary. So that's also quite interesting to look at, the fact that there's such a big difference in terms of what the lowest earner makes as well as what the highest earner makes in comparison to the mean. Now, the standard deviation, now this simply tells us what the difference in terms of what the difference would be amongst the salaries that people are earning. So if you were to add the standard deviation value, which is the 10,400 to the mean, you're able to understand how much people in this group, so how much two-thirds of my population size earn, okay? So if you were to take the standard deviation and then you look at it you add that to the mean statistic, which is 17,000, you'd get the highest value to be 27,000. And if you were to subtract that from the mean statistic, you would find that it's 7,000 Kenya shillings. So what that simply tells you is that over 60% of the people in my test or my analysis earn between 7,000 Kenya shillings and 27,000 Kenya shillings, okay? So that's something you'd want to confirm. But then of course, that's also dependent on why there's an outlier here. There's there's individuals or an individual who's clearly earning more than the rest of the group. So you can find that the mean is being affected by the outliers that exist in my study. Now, the variance simply tells us of how this standard deviation is being affected and to what extent it is having an influence on the different salaries that people can earn. Now, if you look at the skewness, so the skewness simply represents, if there wasn't a histogram, it simply tells you, if it's positive, then it means that it is skewed to the left, that your data, a lot of your data will be found to the left side of the histogram, which is clearly evidenced here. So you do find that in the histogram, a lot of the respondents seem to be falling under the left side of my histogram, which you can see here, the frequency, a lot of them. So over 30 people are clearly in the earning range of 14,000 or so. That seems to be what's represented there. And then the kurtosis, what this means is it just shows you on which side of the tail individuals or like your data is being represented as. So you find that in this case, the kurtosis is negative. Now, if you are to have a graphical representation of this, it simply means that there is something odd, or rather the tail end to the right of your histogram is definitely being affected by specific statistics that are on there. So in this case, you can attribute the fact that this kurtosis, so that your data is very heavy on the right side of the tail, is being attributed by this outlier right here. Okay, so what it means is often you'd want your kurtosis to be lower or a little bit higher in this case than this, because it means that your data would be normal, like it would be a normal distribution. So in this case, the negative simply just represents, is a reflection of the fact that I do have an outlier here. So someone who's definitely earning a little bit more than others. So when you look at this, what you do also end up identifying is that we haven't had a lot of information when it comes to the mode, or even having to try and understand some of the data, or find a little bit more descriptive statistics. So this is quite easy to access. One way you can do so is simply by going back onto Analyze. Once again, if you go onto descriptive statistics, you are able to click on Explore. Now, what Explore does is that it's simply, you're now able to get the mode, we would now also be able to get the mean, okay? So if you were to play around and just try and analyze the average salary, you would then try and see what plots or what different settings you would want to read. So descriptives is automatically checked for you already, so you can accept that. You can also go on and try and see if you want, you can select a stem and leaf, a histogram once more, if you want to, normality test, if you want to, and then go on and continue with trying to identify or see what further your descriptive statistics further state. So if you are to run that, you find that now it is represented in a column format. Okay, so you find that here you are now able to see a median. You are also now able to get other statistics such as the interquartile range. You get the range as well represented, and all these different data that you didn't have before. So here, if you look at the median, so you find that what the median simply tells you is that the lower half of your, majority of the lower half of your individuals clearly earn 14,999, as well as the upper half of your a majority of them earn 14,999. So that's the importance or the significance of getting that. Similarly, the same histogram has been drawn up for us. So if you want to interpret that and write it as it is, that's completely up to you. One thing I would like to show you is known as the stem and leaf plot. So these are quite useful in terms of trying to understand how many people, how much, in this case for salary, how many people in terms of frequency earn a specific amount of salary. So what you see here, if you were to look at it, it does somewhat seem as though an inverted histogram, how it is drafted up. So what that means is that you can see that a frequency of 5 people earn 2,000, or the 2 twos. Now the stem would have represented in the 10,000s. So anything that is 10,000 and above. And in this case, you find that 5 people don't even earn close enough to 10,000. So they earn the 2,000 range. So that's the 2,999 that's being represented. You find that another 11 people also don't earn in the range of 10,000. So you find that these people are earning 7,000 Kenya shillings. And then similarly, when you go into the 10,000s, so the 1 represents 10,000, and these are other thousands. So 30 people earn 14,000. So 10 plus the first 4,000, you find that 30 people are earning 14,000 and above. Now, the most interesting bit as well is that you do have extremes. So what these extremes represent is, you would say that they're outliers. So 13 people have or earn above 35,000 Kenya shillings. So that's quite telling of the information or the data that you have, that these 13 people definitely skew or have an impact in terms of how your data is being represented. Now, another way you can also try and read your descriptive statistics is that you can try and look at it. So something like salary, you can try and look at it in comparison to another variable. So perhaps let's say you want to understand it according to gender. So how you'd start with that is that, of course, for your gender, you know that you either have a male or female. So you simply need to split that variable, the gender variable. So in order to do so, you need to go onto data. You need to go onto splitting your file. And then you need to select, in this case, gender. Now here, the automatic setting lies that you will be analyzing all cases and you do not need to create groups. But in this case, you're interested in trying to identify or understand how gender affects the salary. So you simply compare groups. You're going to need to go for that second option. You move that onto the groups based box, and then you press OK, right? So that has already been created for you. It's just an execution. Now to understand, now to analyze your data. So if you want to analyze your descriptive statistics according to gender, you simply go to Analyze. You go on to Descriptive Statistics. You select Descriptives. You select your average salary is already selected. So there you go. And then now you can place gender as well on there. You make sure that the items you're trying to understand, so the descriptives, the variance, the range, your kurtosis, and skewness are also selected, and you simply continue. So now when you look at your descriptive statistics, sorry, just need to move an icon. When you select your descriptive statistics, when you select your descriptive statistics, what you see now is that it has been represented according to the different sexes that exist. So you have the male category being represented, and you also have the female one. If you identify how many men participated in my study, then you see that it is 39 of them. For females, you can see that it is 21 women who participated in this study. Now, similarly, it gives you the data or information that you've been looking at. So your range, so for men, the highest salary, the difference between the highest salary and the lowest one is 32,000, whereas for women, it's 34,000. So that's also quite an interesting distinction, or quite an interesting item for me to look at. In my study, at least for what this showcases right now, is that women have a higher range statistic. And perhaps this may also mean that women in this case may be earning, may have an outlier in their statistics or in their data. And I may find that some of the women are earning high salaries. Right? So of course that's dependent that I need to look at the minimum statistic, where for both cases, both men and women, it's different. It's similar, sorry. And however, when it comes to the maximum statistic, it's different. I find that women in this case have one person who is earning 37,000 Kenya shillings, whereas for men, the highest statistic or the highest salary that they're earning is 34,900. Now the mean is quite close for both. So 16,000, although it is a distinction, 16,000, 17,000, but the standard deviation is quite interesting. So what this means is that there's quite a huge gap in terms of the highest, the salary, particularly for women, what the lowest person is earning and what the highest person is earning. And there's also quite a telling that over the 60% of women in my study, so the 66%, there's quite an interesting gap from the mean. So it would be that over 60% of these women earn between 5,000. So if you were to take the 12,000 minus 17,000, you get 5,000. And if you were to add it to the mean once again, you get nearly 30,000. So between 60%, they earn between 5,000 Kenya shillings and 30,000 Kenya shillings. Quite an interesting dynamic. So once again, of course, if you were to look at the skewness, you find that they're positive. So they both go to the left side of the histogram. Okay, so a lot of them earn between 10,000 to 30. But when it comes to the kurtosis, so the heaviness of the histogram, you find that the men actually have a very good histogram. So you can draw that up, you can create those and try and understand what exactly is, what is the normality, or how normal is the histogram in this case. So you find that for the men, it's quite normal distribution in a sense, but for the women, it is heavily tailed to the right side. So a lot of the values lie in the 30,000s, okay? All right, so are there any questions before I proceed, or any clarifications that you may need? Please remember, you are more than free to ask any questions in the chat section, or you may also raise your hand and ask away. So for the descriptive statistics, I will, if there's any more, I do encourage you to go ahead, download the SPSS software, and then try and practice it. Use it to whatever data you have, or if you want me to send you any data, please do so. Drop a message in the ASF, or you're also able to ask for such in today's session. So now what we will move on to is the exploratory factor analysis, okay? So exploratory factor analysis, just getting a few details here. We are now going to see or try and understand the relationships that may exist amongst the variables that I have. So I'll minimize that one for now. Okay, so we'll come back to it shortly. Now, understanding the relationships amongst my variables, what that simply means as well is that if you were to look at some of the data that I have, so the bonding social capital, right? So recall that this is the, remember that those are the relationships that exist, the close-knit relationships that people have with either friends or family members, me trying to understand how that may help them or helps them in their business endeavors. So I'm trying to, what I will be trying to do is to try and see if I can create a single variable that represents all these items, or try and identify which are the most important ones for me to use in my study, so in my main study, right? So the exploratory factor analysis, there's two steps that you need to do so. So the first one that we'll look at is the dimension reduction. Now, once you have that and you get some information from that, then what, of course, you want to run is the reliability test to confirm and try and see if the relationships amongst these variables that you've chosen are actually good enough for you to conduct your factor analysis with. So we'll start with an easy one. And what I mean by that is just starting with a dimension reduction for variables that are all, that simply create one factor. And it's easy for me to simply group those and create one single variable that now represents all of them. So of course, I've run my data over and over again. So I'm quite familiar with which ones work well and which ones may need, which ones I can take out. So we'll look at business performance in this case. So for business performance, if I was to start and to try and look at my dimension reduction. Now, how to go about this is that you start by selecting Analyze. Now you want to do dimension reduction. So all these terms are represented on your SPSS software and you can easily access them. So dimension reduction, what I will be doing is the factor analysis. So the factor analysis is highlighted. You can see already selected, pre-selected. You need to look at the left box that represents all your variables. So on here, you can see that I'm scrolling through each and every single one of them. But what I'm looking for is the business performance. So I simply start selecting each and every single one of them. So the business performance 1, 2, 3, 4, 5, and 6. Now I move those onto the right box. And then I need to have certain settings that are ideal for me to be able to analyze these variables. So I click on descriptives. I may want to get some univariate descriptives. Now remember, the most important thing that you're trying to look for as well here is the KMO and Bartlett's test, because that will let you know if these variables that you've selected, are they even worthy to begin with to conduct factor analysis with. I may want to look at determinant. Significance level is quite important. And you can also look at the coefficients, okay? And then if you were to go on to extraction, now remember there's the most two common ones is principal components analysis, and you also have the principal axis factoring. So here is where you're able to select which one you feel as though would be ideal for you. Now, principal components analysis, which is the PCA, is what I go for. And what I may also want to learn or to look at is the scree plot. Now, the importance of having the scree plot on there is simply because you want to be able to see if what the table, so your factoring table, is telling you, is your scree plot collaborating with it? Does it show you that those same factors that your table is pointing at is the scree plot reflecting that indeed you should use those number of factors? Okay, so it's dependent on, it's highly useful, of course, when you get a number of different factors for the variables that you've used. So in this case, I'll leave the normal settings that are on there. So proceed with that. For these ones, you want to go for varimax. Now, the reason you select this, the varimax, is because it will give you every single variation, or it will create different factors until it ensures that you have the appropriate factors, or reflects how significant the variable is for that, or loading onto that particular factor. So it gives you every single possible outcome. And the very last one, so however number of times it rotates it, the very last one is most likely the appropriate number of factors that you should use. Okay, so you select continue. These I will show you how to manipulate after. Okay, so in this case, you're ready to go, press OK. You have a look at the factor analysis. So it's drawn up. It also gives you descriptive statistics. So that's one thing to note. You see that you get your mean, your standard deviation, and the analysis. Now, in this case, if you were to notice what it's done, it's divided it up according to the different sexes. So, and this is as a result of me splitting the file. So what you do need to do in this case is you need to go to data. You need to go back to split file. You need to deselect, or rather place that back onto the right box and say that you're analyzing all cases, all right? Because then that you're moving on to more specific details. So once again, I will go back to analyze, dimension reduction. So I'm simply doing this because I want to look at the variables without necessarily having to look at gender having a play or influencing it. So all my settings are still in place. So whatever I had selected initially, so no need to change anything. I will once again press OK. And now I have my information without it having to split it into the different, whether it's male or female. So I have, once again, descriptive statistics. So this is the mean for each and every single one of the variables. So from 1 all the way to 6. It shows you the correlation. So how the different variables correlate with each other. You can see for some of them, they have quite a high correlation. Business performance 1 and 2 have quite a high correlation. So it's good to perhaps try and also look at this area and try and understand how your variables relate to one another. But if you remember, the most important things you're looking for here is the KMO and Bartlett's test. Now here, it gives you a very small table that's quite precise. Recall that for the KMO to tell us the appropriateness of our data, you can set it as anything that's closer to 1 means that your data is quite good. Now in doing so, try and make sure also as well, anything that's less than 0.6, I would advise that you discard the variables, or rather the instrument, try and adjust the instrument that you have been using, as well as try and look at the data that you have. The significance of the Bartlett's test, remember that we want that as well. So we want anything that's lower than 0.05. Now in this case, this is quite low, so it's good. So we have our KMO test shows us that it's 0.85, which is good, means that we'd want to use these variables that I have. So the business performance, whether I'm looking at profitability or sales and growth, they seem to be good. Now, communalities is also something that I mentioned in our talk. So communalities are important because it just shows you how much each and every single variable loaded into this particular analysis that you ran. So the factors, you find that 76% of the first variable was used in running or generating the results that you have. 84% of the second variable, so and so on and so forth for each and every single one of those variables. Now, if you look at this, this is quite good for the variables that I've used, and simply because I only get to use one factor. So all these different variables that I have, all the way running from 1 to 6, what that means is that I can now compute or add all these different variables and only have one factor that represents business performance. So I'll use that in any other analysis. Once I add all of them together, that is what I will use, or I can use that to try and run any other analysis, referring to them as business performance. Another area or another thing that you'd want to use, now the scree plot in this case is in agreement with the total variance. So that's good. You see that you only look for where your eigenvalue ends up having quite a huge distance from one another. So in this case, you only see that it's 1 on here. So perhaps assuming if there was supposed to be another one here, somewhere here along this line, then what that means is that we would have 2 factors, or we would generate 2 new variables that would represent business performance. But in this case, it showcases that everything is well within the setting. So I don't know if Dr. Sheon Kolade is still in the room. I would like to give him a few minutes before I proceed for him to say something. And then we can proceed from there to look at using exploratory factor analysis as well.
Well, yes, thank you very much, Tracy. I'm here. Unfortunately, I have a meeting in about 5 minutes or so, but thank you for the session. So far, I had to be in another meeting, and thank you also for Kinde, Dr. Medase, who is also a facilitator in this series. I think, I don't know, maybe I could just give you, stop sharing.
Yep.
1 minute so that I can just maybe show my screen.
There we go.
Yeah, I can try to show my screen and just add a few things, if I may, within this short time. But if there are any questions, please feel free to ask. Tracy is, of course, going to continue to be in the room, and Dr. Medase is also here to answer your question. If just give me a moment, and I would pull out the updated data. Maybe not so much updated. I think Tracy probably has the latest version of our data. But yeah, so I would just open one of them to emphasize 1 or 2 things, just to buttress, what Tracy has been saying. If you give me a moment, the data is opening. But I hope that folks have found the session useful. And like I said, if there are any questions, please feel free to ask. Right. So, okay, let's see whether this data has opened. So with descriptive statistics, it gives you a broad sense, a sense, and this is part of what you report, whether you are for your thesis or for your paper, or about the structure of your data, about what are the maximums and minimum, what are the mean, standard deviation, and all of that. And sometimes you also run the correlation metrics, which show the relationship between your various variables. Well, the exploratory factor analysis is then important. It's an important next step in terms of figuring out how your variables are holding up. Okay, I think the data has loaded now, and I'll just take a couple of minutes really before handing over back to Tracy. Okay, so can I share actually? Is it possible for me to share? Let me see. I think I can. Yeah, I can share. Okay, perfect. Yeah, all right. So let me share my screen in a moment. So I imagine you can see, so this is the same data that you have been looking at, Tracy's data. And I think with regard to exploratory factor analysis, it works by dimension reduction. Yeah, this is another call coming through now, unfortunately. I think I'll join them later. So just a quick one. I think Tracy has shown you, how it works when you are running. So this is what you do before you do the reliability analysis. So, but with this, I just want to quickly show something, and I hope that will be fine. So when you have to deal with multiple factors, which is I hope I can find some right one here. In terms of the social capital. If Tracy can try to help me here. Which one is it? Which one will give us that?
Okay. A little bit. Yeah, you found. So
okay. If you have the bonding beads and all of that stuff.
If you go up a little bit further, slightly.
All right. Yeah. Further?
Just a few, no, not further down, further up. So if you scroll.
Oh, further up.
Yeah. I think, because this is, could you select the data? Yep. So you have structural holds there if you'd want to use those.
Which one is it?
Structural holds is so there where you are now, you have the social capital elements or the variables.
Yeah, so there are some social capital elements there. Okay, let me just go further down and just at least show something, just for the sake of it, and see what it brings. So with the bonding, I think there's some bonding here. So yeah, so let's see. I'm trying to look at these items and just trying to find out, because I think the example that Tracy gave you is good, but there's only one factor there. So I think you're going to find that. Okay, let's try this one. So where you have, more than one factor, so potentially more than one factors, we don't know. So this, you are choosing here the extraction method. I think will you go with, yeah, maybe principal axis factoring or something like that. And that. And the rotation, yeah, let's choose Varimax. I think you've gone through all of that stuff before. And let's just see, what does this give us? So this is you're running the factor analysis here. And so you can see here now that we have two factors. So this is where I wanted to go to very quickly. So we have two factors. If you use this extraction method, and the first one has, the eigen value of this, 0.962, and the other one is that. But I just want to look at these, when you then inspect them to see which one are the factor one. Okay, this is probably not the best example as such, but you can see what is happening here. So generally you are looking for items that have more than 0.5 in terms of the factor loading. So you can see that with factor one, you have, bonding the item one, item two, and then this one, 1, 2, 3, 4, 5, and 6, and 7, and 8, and 9. Those are actually, factor one, and then you add this factor two, where the only one there actually that is significant there is this. But like I say, Tracy will probably show you a bit more of these. Yeah. This is probably not the best set of items, but it's just to show you that where you have more than one factors, your analysis, your exploratory factor analysis is going to show you the loadings of each of them. And then it's also going to, a lot of time, it's also going to show you, sometimes it also arranges it for you in order. Yeah. So if we go here now, for example, it's unrotated, I don't want unrotated. So also the way, let's choose that and see what it gives us. so you can change, different aspects of it. You can change the, so here we've included the script plot that you can see. And again, you can see also here again, so when you, so you can run this also using different methods just to compare and see, and then, to confirm, how valid, how strong they are. So here again, you can see the same pattern broadly holding, although here you have about 2 factors now that are, okay, maybe 1 still, that is more than 0.6. And all that, using this different extraction method, which is principal component analysis. But yeah, so I will hand over back to Tracy. I know, time is, when you still have about half an hour or so. I have to be in another meeting. But thank you, Tracy, and thank you, Kende, for anchoring this. I'm sure that, the next session, there are likely to be more people attending. A number of people have got in touch with me earlier today, trying to find the link and all of that. So maybe there are some issues we need to solve there for them. But I'm sure that will not be a problem going forward. I just want to stop sharing. So back to you, Tracy.
All right, thank you, Dr. Schoen. We'll talk to you shortly in a bit. Okay, so I'm going back to sharing my screen and back to what we were looking at. Now, so as Dr. Schoen has mentioned, this particular exploratory dimension reduction that I've looked at is more or less has been perfect in terms of how the data has been, what it results in, so how many factors it gives me. So that is if you're lucky enough to find variables, and once you've run it, if you're lucky enough to find variables that can easily be reduced into a single factor. Now, in the case whereby you have many other different variables, and you'd want to narrow it down into factors that would well represent what you're trying to measure, then you do end up having to conduct this exploratory factor analysis once again to try and see how many factors, or rather how many variables you can reduce the number you have. So in this case, we can look at linking social capital. Now, I think this is a good example because you'll find that I have 15 different variables that are trying to analyze how useful are the links that these individuals have. So these refugees, the entrepreneurs, how useful are the links that they have with whether it's senior officials, so government officials, or it's the non-governmental organizations, or even banks. That is, how useful are these, how useful are those variables, and are these network connections that they have? So we'll look at the linking social capital element in this case, and we'll run an exploratory factor analysis to try and understand which of these variables are quite useful for me to use in my main study. So how you go about this, once again, is you simply go to analyze. So you have the dimension reduction element. So you start with factor analysis. So here you have all of this that have been selected. So place all of that back so you can reset it. And then you simply now start placing the linking social capital variables that I have. So in this case, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 variables. So the gender one, you place that back because you're not trying to add that to your linking social capital variable or element. So here are all the linking social capital variables being analyzed in this case. So you need to set your what it is you want to look for. Now remember, you are running the exploratory factor analysis. So your KMO is going to be one of the key things that tells you whether or not these variables are quite useful for you. You can have a number of other settings in place that help you understand your data. I will still stick to using the PCA to show you what results would come about. So that is selected. The scree plot, once again, we will set these as they are. We'll leave the settings that have been provided for us. And then in this case, rotation, once again, you want varimax because you want it to give you every single possible variation of the factors until it gives you the appropriate number of different factors that you would find. So you select that as well. Now, for the other two, the scores, you ignore that as it is. When it comes to the options, as mentioned, you are able to sort them according to how you'd want them. Now, I'll show you why the suppress small coefficients is quite important, but I'll come back to that once we've looked at the different, what our results will tell us. So you have those settings. You can press continue, and it will run that for you. Now, here are your descriptive statistics once again. You have the correlation matrix that shows you how the variables intercorrelate with each other. And then the KMO test. Remember that we're looking for anything that's above 0.6. In this case, you have established that you will retain or you will use the variables. So this is a very good result. You have a 0.7. And also for the Bartlett's test, you have a significance that's less than 0.05. So that's quite good as well. Now remember, the communalities simply show you how much each and every single variable has loaded into your analysis. So you have all the statistics. So these can be converted into percentages, and you're able to determine that for linking social capital 1, whatever that was measuring, then 73% of that has loaded on there. Now, if you look at the variance, so the components, so the number of different variables that the analysis is suggesting for you, it's telling you that there's 5 different factors that you can create from these 15 variables that you have used. Now that's quite a lot to begin with. And also you'd want to see that if are they all really important? So are they really all above 0.6? Or depending on the cutoff mark that you set for yourself, in my case 0.7, are they all above that? So if you look at your scree plot, as I said, the scree plot, you use it to match it against the total variance table. So you see that here it's telling me 5. But if I look at my scree plot, it's simply telling me that there's 1 that seems to be useful in terms of using it as my variable or creating the new factor. So what I need to do now is also study the different component matrices that have been created. So the component matrices, each and every single one of them shows you where they've been loading, so where the variables have been loading. So you'll find that for question 1, you have certain factors that load onto it. For question 2, you have certain factors that load onto it, and so on and so forth. But then, of course, that becomes a challenge. You can see that for this particular analysis, the first component matrix was not enough. So it needed to run that again. And if you notice as well, you see that the values here are negative, and you really don't want that, because then that means how your questions have been worded, maybe in a negative context. So it may suggest that perhaps you need to run it, but that is the usefulness of using varimax, because it tries and ensures that when you're drawing out your factors, that they are in a positive construct, or rather their representation is positive. So if you were to look at the first one, you notice that the LSC 11, the 10, 11, 12, and 13, the first 4, are all negative. But if you look at the second rotated component, you realize that they've been converted and they're now positive, right? So you look at that and you analyze, and you realize that that is probably one of the strongest variables that the 4 of the strongest variables that you have in your study or your instrument. And then you also realize that for the component matrix, the second one, the second factor, you have that LSC 5, 6, and 9 are quite high as well. So they're above the 0.7. that I've set as a mark or as a cutoff point for all the data that I would want to use. Now here you find that for the third one, you only have LSC, the linking social capital 1, 4, and 2, rather the 1 and 4 alone. And then here you only have 15, and here you only have 8. Now for my own research, how I have set it is that if I've run my exploratory factor analysis and I find that a factor only has one variable representing it, I will not use that factor. So I discard the factor. So in this case, you'll find that my new instrument or my new questionnaire doesn't have LSC 8, and it also doesn't have LSC 15. And then in the case of 1 and 4, I'm also contemplating if I'd really want to use them. So I can get a better representation of this simply by going back to the analyze and dimension reduction section and then running my factor analysis once again. But in this case, removing, so I can set where you have the suppressed small coefficients, you can set that to 0.7. Now what that means is that it will bring up every single, the factors that only load above 0.7. So it gives you a better visual representation of your data. And so if you do so, you're able to now see, if you scroll down back to your results, so same results that have popped up, but now what you see is that the other numbers have been eliminated. So now I'm able to see clearly and even better what my data is trying to tell me. Now, all these different components that have been created, you need to ensure that they're reliable. Now, this is where the reliability test comes in. This is where you run it to look at the Cronbach's alpha and try and see whether or not the relationship that exists between the new variables that are creating the factors are truly worthy using. So how to do so is you've seen that your new factors, so factor 1, assume, let's say for this case, we will only retain factor 1, which is the variable, which the variables that represent it are LSC 10 to 13, and we'll also retain factor 2, which is represented by 5, 6, and 9. So to ensure or to check their reliability, how you'd run this is you once again go on to analyze. This time you go on to scale. Reliability analysis is highlighted for you. And then as you do that, you now compare. So have your table side by side. As you can see, in this case, my variables that I want to test and where I'll be drawing them from. So I want to see how good is the relationship, or what is the correlation of these elements for the factor. So variable 10, 11, 12, and 13. How good are they? I want to understand how reliable will they be for me to use in my confirmatory factor analysis. So here you need to set whatever statistics you'd want to analyze. Now, the most important one is scale if item is deleted, right? So this is important because remember, you're looking for the Cronbach's alpha. Now, anything in your Cronbach's alpha that's above 0.5 or above 0.6, depending on what you set for yourself, then that means then you can use the variables that you're looking at. You'd also want to look at scale, and you'd also want to find the items. You'd want to look at the inter-item correlation, so how each and every single variable correlates with each other and covariances with each other. If you want as well, you can get some more descriptive statistics, and you can select each and every single one of those. Now, when you press continue and you say okay, the first thing that you should be looking at is ensuring that it has analyzed all your data. So here you see that it states that it's looked at the 60 participants, or the information that is fully provided on your data sheet. the Cronbach's alpha should be above 0.5. Now, if you look at this one for linking social capital at 10, 11, 12, 13, it's quite high. So this is very good. 0.925 is quite good for you to have. So in this case, it gives you the item statistics. Once again, if you don't want to read into those and try and understand the standard deviation in each and mean, you're more than free to do so. The intercorrelation matrix shows you how each and every single one of them correlates to each other. So of course, LSC 10 against itself correlates at 1, but you can also see that it has quite high correlations with all the others. So 0.86 for this one, for 11, 0.73 for 12, 0.73 for 13. So those are quite good statistics or like data to have gotten. Now, the most important thing that I mentioned was scale if item is deleted is important because what it says is, assuming that my Cronbach's alpha came back and it was less than 0.5, what it does is, if you delete the item, so assuming if I was to delete LSC 10 from my study, from this analysis, then the Cronbach's alpha would be 0.903. So if it was less than 0.5, then that would mean that if I took out the LSC 10, then my Cronbach's alpha would improve, and that would mean I should only keep LSC 11, 12, and 13. So it's quite a useful tool in terms of identifying and understanding the variables that you have. Now, what this simply means, given that my Cronbach's alpha is good, 0.925, it now means that I can retain LSC 10, 11, 12, and 13. Now, I can easily also create a new variable that represents all these three. Now, how to do so is quite simple. So you realize that your LSC 10, 11, 12, and 13 are represented here. So you have them there. What you want to do is now create a new variable that has all those three things, okay? So what you want to do is go on to transform, select compute, because you want to add all those variables together and have a new variable that represents them. So how you go about this is on here under computing your variables, all you simply have to do is have the variables, you get the variables provided to you. You can now select them one by one. So you send them on there. You add them, plus your LS11, plus your LS12, plus your LS13. Okay. Now you can give this new variable a name. So I could call it link social capital in caps lock, because social capital 1. So that represents my new variable, the new variable that represents my top key linking social variables that I'm retaining, okay? So if you press OK, what it does is it says that it's computed and saved them. So you need to confirm that you now have this new variable. And you simply do that by going back to your table. So here, if you check, you find that you have it. So it has been reflected. And if you had to look at the data view, so on there, you simply, if you double click, it shows you its computation. So this is all those variables added together. So the numbers that are now represented on here are all those different variables having been added together. And it shows you that my study, and from my analysis, what that means is I have only retained these three, so 10, 11, 12, and 13 as the first factor, as the new variable now. Similarly, I can do that as well with the second factor. So I'd simply need to run another reliability test. I'd need to select all of them and place them back. Now for your second factor, you have 5, 6, and 9. So you simply need to select them. So 5, 6, and 9. Okay, so my statistics remain the same because I have not reset anything. So all is well. And if I was to click OK, similarly, my Cronbach's alpha is quite good. So 8 is 0.80. So that means I retain LSC 5, 6, and 9 and use them in my study. And I simply also as well, likewise, just add them all up together. So I can label that LSC2. Add them all together. LSC5, 6, and 9. So note that I'm using a comma in computing all these three. Okay, so once you select OK, it confirms that it's computed, and you just need to check as to whether it has been added. So you find that LSC link 2 is there, and if you were to click on it, it shows you the additions of all those 3 items. So if I was to look at my variables, what that means is that under the linking social capital, all the way from 1 to 4, I no longer need them. They're useless to me. I do not need the 7th one because it does not make the cut to me creating a new factor for it. And I no longer need 8 as well. So I delete that. And I also no longer need 14 and 15. So I delete them. Okay, so my new data, or what it is that I will be using in this case, in the case of linking social capital, is 5, which is the influence that people would like more influence over the kind of assistance they get, or the decisions in making decisions that affect the area, that asking them on whether they would like the residents to have influence over neighborhood issues, as well as any other one. So I'd also want to, the most important ones seem to be asking them how much they trust the local authorities, the government, the agencies, as well as to whether they understand the government policies that are in place. So those, these have been deemed to be quite important for my study, right? Okay, so are there any questions in terms of what we've covered today, or any clarifications where one may need? Are there any, I see a hand clap. Thank you very much. Great, so any comments? Right, so I do encourage you to go practice with this. For our future sessions, of course, we do hope that you're also able to access, you have SPSS on hand, and then we'll create more sessions where we all do a practical approach together. That way you're able to follow through. So step by step, every single action that will be taking place on my end or in Kehinda's end in this case, you're able to follow through in each and every single one of them. All right, so thank you very much everyone for attending this session. I hope that I have been able to enlighten you in some way. So if there's any assistance that you need, or any assistance in terms of getting even SPSS, or how to access it or find it, please do reach out. Do remember that we do have a second session of our workshop, our skills workshop, taking place. So we'll be looking at introduction to OLS and two-stage least square regression. That's one I'm very interested in, because I am also using the two-stage least square regression for my work. and Kehinde Medase will be delivering that this Friday, same time at 12 p.m. Right? To simply access it, I will post the link on our ASF platform, as well as share the flyer for these sessions. I wish you a very good rest of the day and a lovely week ahead. And thank you so much for attending. Goodbye, everyone. Thank you, Ayatare, for the comments. Thank you, Kehinde, as well.
Thank you.